Hello, Professor. My name is Badri Narayan, and this is my submission for CISC610 Assignment 1. In this assignment, we'll be considering some well-known algorithms and problems and analyze the general complexity and efficiency of these algorithms. We'll be going through insertion sort, traveling salesman problem, sum of a 3D array, a radix sort, and brute force password cracker. Moving on to the solutions. The first one is the solution for the insertion sort. I have a method here that does the insertion sort function. Insertion sort basically is sorting an array in place. The big O notation for this is O of n square. This is because we have to iterate through the whole array at least once, and also we'll have for each element we'll have to sort the current element based on its based on what the correct sorted position is. So since there are two operations involved, the big O notation is O of n square. The best case scenario for the for in this case is a sorted array where all the elements are already sorted. For that case, we'll have to iterate through each of the element at least once. So the complexity case for that is O of n. The worst case is array that is completely not sorted. So for each element, will have to be each element have to be read once and then moved from its current position to the sorted position. The complexity class is P, since this can be solved. This can be solved as a quadratic polynomial equation. I'm going to run the code once to make sure it's running. And we see that we've given an unsorted list, and we have a sorted list as output. Moving on to the next problem. The next problem is the traveling salesman problem. The problem is basically how a salesman starting from one city can go to n cities and come back to the starting point in the shortest time. Um, so, for example, when we take a simple case, for example, if there are 5 cities, then by brute force, the number of solutions would be 5 minus 1, which is 4 factorial, which is 24 different routes. Um, so, in general, the big O notation is O of n factorial, where n is the number of cities to be visited. This is the worst case scenario for this problem. There are other possibly better solutions which can be achieved through dynamic programming. For example, it is possible to achieve O of n square into 2 power n using dynamic programming, but since we are considering worst case scenarios here, the big O notation for this would be n factorial. And the complexity class for this problem is NP hard. The reason being that the runtime of this program depends on the method that we use to solve, and there is no specific algorithm to solve this kind of problem. But the verification of the solution once it is found can be done easily. Therefore, this problem is classified as NP hard. Moving on to the next problem, sum of all values in a 3D array, n cross n cross n, which is each n represents a dimension, length, breadth, and height. N's can be same value or different value. Um, so the code here is a small function that we use to calculate the sum of all the elements in the array. The big O notation for this is O of n cube, since we'll have to iterate through each element once, and in order to achieve that, we are using 3 for loops where we read each element and add it to the sum, which is initialized as 0. The complexity class of this problem is also P because it is a cubic polynomial equation that can be easily solved. The next algorithm is the sort algorithm. We'll be using the reference code in Geeks for Geeks to discuss this algorithm. Um, so the Reddick sort algorithm, it basically the working is that it initially finds the number of digits present in the largest element in the array, and then it sorts the elements based on the least significant bit. Uh, First, it sorts the elements on the in the ones place, then it sorts the elements in tens place and hundreds place, so on. In order to solve the numbers in each place, ones place, tens place, and hundreds place, the Reddick sort uses counting sort, uh, where a counting sort uses a special algorithm where it calculates the number of occurrences of each element and stores it in a separate count array, and uses an algorithm to return the output as a sorted array. Um, so here the big O notation for this is O of n plus b star log k to the base b, where n is the length of the array and b is the number of digits in the largest number. The reasoning behind this is the uh, uh, in order to understand the reasoning, we first try to get the complexity of the counting sort, which is O of n plus b. Basically, n plus b for the length of array and the number of digits. So this is based on the number of operations that we have to perform on the array in order to sort it. And since radix sort is dependent on doing multiple counting sorts, um, we'll need log of k to the base b, which is the number of times that we'll have to be doing the counting sort. So we arrive at this big O notation of n plus b star log of k to the base b. In case if for smaller values of b, say for example 2 or 3 digit numbers, or this can be the O of n plus b log b of k can be further simplified to O of nk. Again, the complexity class here is also p, since this can be solved uh, in polynomial time. Uh, Moving on to the next problem, the brute force password checker. Uh, the classification here for this password checker is in big O notation is O of k raised to the power n, where n is the length of the password and k is the number of possibilities for each each element in the password or each character in the password. And the complexity class is np complete because um, this we are using a brute force, and there are a number of possibilities, but if we have a correct or if we have a answer, it is easy, very easy, or very we can immediately check if the value is correct or not, and hence we classify this as np complete. Going to the code, here we initialize the guesses. We have the possible strings, which we have numerals from 0 to 9, the lowercase characters and uppercase characters. Um, 26 plus 26 plus 10, which is 62 possibilities for each character. And the password length can be from anywhere from 1 to 8 characters. Uh, and so for every, we use iter tools to guess the password, and we increment the my guesses variable by 1 for every run. This will give us the number of attempts it took to crack the password. Um, So just running the code for a simple password. So it's taken this number of guesses to guess the correct password. Thank you.